is hot, really hot. We know this. Avoiding direct sunlight by stepping into a shadow cools us off on warm days, while stepping out of a shadow into the sun's rays can warm us in the winter. So what happens to temperature during the biggest shadow imaginable, a total solar eclipse? Solar eclipses occur when the Earth, Moon, and Sun all line up with the Moon in the middle, resulting in a shadow along the Sun's apparent path. These three bodies are radically different sizes, are different distances apart, and travel through space at different speeds. Having the three line up from a spot we can see them is somewhat rare. The last total solar eclipse visible from the United States happened 7 years ago on August the 21st, 2017. By total solar eclipse, I mean the sun appears to be completely blocked out by the moon, leaving only the sun's bright outer ring, the corona, visible. Virginia did not experience totality in 2017, with only about 88% maximum coverage. The temperature of the air around us is dependent on the sun. The surface of the Earth absorbs solar radiation and heats up. The ground then warms the air that comes in contact with it through the process of conduction. Air, however, is a poor conductor, with this transfer happening just a few centimeters off the ground. So when the amount of solar radiation decreases, the air loses heat rapidly and cools. An 1834 Gettysburg, Pennsylvania newspaper reported a temperature drop from 78 to 50 degrees during that year's total solar eclipse. Observers in Norway reported a similar drop from 8 to -7 degrees during a 2015 eclipse. Blacksburg reported a 6-degree decrease during 2017's eclipse. As air heats and cools, it also moves. Hot air rises through convection, which drives turbulence in the atmosphere. Cooler winds are less active, so there's less air movement during a total eclipse. This decrease in air movement also affects cloud coverage. NOAA, the National Oceanic and Atmospheric Administration, the federal agency that monitors weather phenomenon, began experimenting with short-term weather forecast models that factor in eclipse activity just prior to the 2017 Great American Solar Eclipse. As of 2021, the agency has put these models into practice, accurately forecasting the impact of a partial solar eclipse that year over the Arctic. This April will be the first time the forecast is used for an eclipse over the continental United States. You can do your own research using an outdoor thermometer. Find a shaded spot that won't experience much light change during the eclipse. Holding your thermometer closer to the ground will allow for more noticeable changes as air temperatures here change more rapidly. Take the temperature several times before, during, and after the eclipse. Compare the numbers and discover for yourself the power of the moon shadow. Thanks for watching. We'll see you in April.